Hi everyone, this is Pragna Pasanuri and I'm here to present my idea on spam filtering using naive-Bayes classification and logistic regression models. So this idea has been developed as part of my coursework EEL 6825 pattern recognition in University of Florida. So as part of this presentation, I would like to cover what exactly is spam and types of spam and problems due to spam emails, and I would also discuss different types of models being developed as part of this project to handle spam emails. And I would also like to cover the comparison of results obtained from different models and conclude on which model would be the best one to find out the spam emails. So let's jump into what exactly is spam. So, email has become one of the most popular ways of communication recently. Email has also become a part of common man's daily life as as email communication incurs very low cost or no cost at all sometimes. And not only in terms of communication, but emails have also gained significance in creating awareness among people, and also they have become a platform for marketing and advertisement. As there are so many advantages of email communication system, it has been become an environment or a platform for spammers to exploit. Spam emails are the malicious emails usually the spammers send to exploit the information or money of the users. And as part of spamming the user's inbox, spammers keep sending bulk emails in order to cheat. There are so many types of spam emails which gained significance recently, but let's discuss the popular ones as part of this presentation. Phishing is one type of spam emails which are like a common type of spam emails. Spammers usually send a fake URL of a popular bank or a social network site as part of the email which they send to the users. Whenever the user clicks on that link and provides his credentials to the URL, the login credentials are tracked and being sent to the spammers, which spammers use later in order to get the information of the users, letting them being exploited by the spammers. This is one such type of spam emails. And let's discuss the next one, the fake advertising emails. Recently, fake advertisement emails have gained so much significance because most of the people who are actually seeking for some devices like the weight loss devices usually get attracted for these kind of emails. Spammers send email to users advertising new devices which provide for example which provide instant weight loss, which attracts the users and tend them to transfer money to the spammers as part of placing the order for the device, which they would never receive from the spammers. And one other spam email type is fake job opportunities. People who usually get attracted to these kind of emails are job seekers. Spammers send emails with fake job advertisements with high salaries, which the user might be interested in. Then the spammer asks the users to transfer the money as part of a initial deposit. When the users transfer the amount, spammers would never reply back to them, leading to a fraud. And one such another type of spam emails are fake lottery emails. People who usually get attracted to these kind of emails are the ones who are interested in lotteries. So spammers usually send emails to users saying that they won a mega lottery and the amount can be reclaimed by providing an initial deposit or providing the bank details to the spam regression model implementation. Logistic regression model can be said as the best model to solve or handle text classification problems. And logistic regression has binary representation of the linear data set being provided as input as the backbone. Mainly, logistic regression involves computation of probabilities of both outcomes and also the likelihood of the probabilities by using the training dataset. These probabilities are usually used to train the model, and logistic transformation equations are being used in classification of emails. So let's get into the flow of the model. Initially, as part of the logistic regression implementation, we process the spam training dataset. So initially, we have considered the dataset which consists of separate spam emails and separate non-spam emails, which are the training data. So as the initial step of logistic regression implementation, we process the spam training data set and identify the spam keywords. And then we also process the non spam training set and identify the non spam keywords. And we use the list of spam keywords and non spam keywords being generated, and we try to generate a common data structure which after building a common data structure which consists of the frequency of the words, both words by words from both the spam and non-spam lists, we then try to process each training email. By training email, I mean both the spam emails and non-spam emails, and then try to compute the spam and ham likelihood for each email and use this number in computing the weights of these words, and we tend to update the weights of the words as we go on in the process. And by updating the weights of all these words, we make the model get ready in terms of training the model. And this process is being repeated depending upon the number of times we want to do it in order to make the model ready and improve the performance of the model. And then we try to iterate through the test emails where we need to identify if the emails are spam or ham. Then we try to iterate through each email, and while processing each email, we compute the spam and ham probabilities by using the likelihood and the weights being calculated previously while we trained the model. And by using these spam and ham probabilities, whenever the spam probability is greater than the ham probability, we tend to classify the email as a spam email, saying that spam the by analyzing all the words in the email, we saw that the likelihood and the words, most of the words or the probability of the words tend to be spam. So in this way, we do an iterative process in order to train the model, and we then process each email to classify the email. As part of the project, another model, Naive Bayes, has also been implemented in performing the email spam filtration. So Naive Bayes has gained so much popularity in solving text classification problems. And as part of the projects, there are two types of implementations being performed for Naive Bayes model. One of them is Naive Bayes model using feature selection. So in this type of a model, the naive Bayes algorithm is performed by using the spam and ham keywords already being selected by performing the feature selection algorithm. And the other model which was implemented is naive Bayes model without using feature selection, where we directly process each test or the training email, both the spam and ham emails, involving the processing of each keyword instead of using the keywords. I mean the keywords, both the spam and ham keywords which are generated as part of the feature selection. So this model, naive Bayes model without using feature selection, is a model which involves processing of each and every word of all the training emails. So let's jump into how the naive Bayes model has been implemented. As part of the naive Bayes theorem implementation, Bayes theorem stands as the backbone of naive-Bayes algorithm. So let's get into what exactly is Bayes theorem. Bayes theorem, it is an intuitive method in finding the probabilities which can be helpful in designing a classifier through the naive-Bayes algorithm. So mathematically, we all know that P of A given B is P of B given A multiplied by P of A by divided by P of B in terms of the Bayes theorem, where P of A and B are the probabilities of event A and B occurring without regards to each other, which means they are independent of each other. And P of A given B is a conditional probability, that the probability of event A given that B is true, and P of B given A is the probability of event B occurring given that event A is true. How exactly is Bayes theorem applied in terms of the naive Bayes implementation will be explained in the next. So here is the flow of the naive-Bayes model being implemented. So initially, when we start the naive-Bayes model, we have two different types of implementations for naive-Bayes model. One which uses the feature selection and the other one which does not use the feature selection. So when we start the process, if we choose to use the feature selection algorithm, then we have a list of spam words and ham words being already generated by using the feature selection algorithm. And those words are being generated from the training dataset. And those words are fed into the naive-Bayes model where we use the, so this in this flow we can see that we are using the existing spam and ham keywords. And then by using these two lists, we create or generate a common data structure of spam and ham keywords. And that common data structure consists of the unique words, and each word is associated with a parameter which says if it is a spam word or a ham word, as we have a common data structure instead of separate ones. And now we compute the prior probabilities. So prior probability in our case is the, for example, if we consider the prior probability of spam keywords, it is the number of, so the probability of spam keywords in the total number of keywords. And when we consider the ham keywords, it is the probability of total ham keywords in the total number of keywords. And after calculating the prior probabilities, which will be useful in the naive-Bayes theorem, we then compute the spam and ham word frequencies, and then we compute the evaluation probabilities by using the existing prior probabilities. Then then we try to iterate through the test. So the model is being made ready by using the trained dataset, and then as the next step we iterate through all the emails of the test dataset, where we need to identify if the emails are spam or ham. And for each email we tend to compute the posterior probabilities, and by using the spam and ham probabilities we identify what type of an email it is and classify it under spam or ham email. So if we do not include feature selection as part of the naive-Bayes model implementation, then we will have to process each keyword of all the training emails in order to identify what are the spam keywords or the ham keywords. So we are skipping the so in by not using the feature selection algorithm, we are skipping the step of processing and identifying the spam and ham keywords. Instead, we are just jumping into processing each keyword and putting them into a common data structure where we have a property for each word saying if it is a spam or ham. And then the procedure is performed in the similar way where we compute the prior probabilities and the evaluation criteria, and then the posterior probabilities, and we use it for the classification. So this is so far the flow of the model. And let's jump into the